Now the next question in distance in section formula says that show that the points 0 comma minus 2, 3 comma 1, 0 comma 4 and minus 3 comma 1 are the vertices of a square. Also find the area of the square. So we need to prove that these are the vertices of a square. What are the conditions for a particular points, 4 particular points to be the vertices of a square? All the sides of the square are equal and also its diagonals, both of its diagonals are equal. So if we prove that all the 4 sides are equal plus that the diagonals are equal, we will prove that these are the vertices of a square. So let's start the question by marking all these into points. Let A equal to 0 comma minus 2, B equal to 3 comma 1, C equal to 0 comma 4 and D equal to minus 3 comma 1. Now we have the 4 points as A, B, C and D. Now we will calculate the length AB or the distance between A and B. So the distance between A and B would be under root of 3 minus 0 whole square plus 1 minus of minus 2 whole square. So this would be equal to 3 square is 9 plus 1 plus 2, 3 square is 9. So this will be equal to under root of 9 plus 9, that is equal to 18. Next we'll calculate the length BC, that will be equal to under root of, we have 0 minus 3 whole square plus 4 minus 1 whole square. So now this is equal to 3 square plus 3 square, that is equal to under root of 9 plus 9, that is under root of 18. Now we will calculate the length CD, that is equal to minus 3 minus 0 under root of minus 3 minus 0 whole square plus 1 minus 4 whole square. This is equal to minus 3 whole square is 9, 1 minus 4 is again minus 3 whole square is 9. So this is equal to under root of 18. Now next we have the length DA. Now the length DA will be equal to minus 3 minus 0 under root of minus 3 minus 0 whole square plus 1 minus of minus 2, 1 minus of minus 2 whole square. So now this is again equal to 3 square plus 1 plus 2 is 3 square, that is equal to under root of 9 plus 9, that is 18. So now we have proven that AB, BC, CD and DA are equal. So we have AB is equal to BC is equal to CD is equal to DA. Now if we have a square over here with points A, B, C and D, we have proven that all the sides, all the 4 sides of the square are equal. Now if all the 4 sides of the square are equal, what else do we have to prove? We have to prove that both the diagonals of the square are also equal. So the diagonals of the square are AC and BD. Now let's find out the length of AC, C and A. So we have 0 minus 0 under root of 0 minus 0 whole square plus 4 minus of minus 2 whole square plus 4 minus of minus 2 whole square, right? So this is equal to 0 plus 6 square, that is equal to under root of 36, that is equal to 6. Am I right? Next we have to now find out the length of BD, that is the other diagonal. So now the length of BD would be found by minus 3 root of minus 3 whole square plus 1 minus 1 whole square. So this is equal to minus 6 whole square plus 0. So this is equal to under root of 36 again, that is equal to 6. Now we have proven that AC is equal to BD. Now if all the four sides of the square are equal and also its diagonals are equal, hence these 4 points belong to a square, are the vertices of a square. So now I'll just write down the statement. Since all the four sides are equal and also the diagonals are equal, hence these 4 points are the vertices of a square. Now we've proven that it is a square. Next, what do we have to do is also find the area of the square. Now what is the area of the square? Area of the square is equal to side into side or side square. What is one side of square? That is AB or BC, because all of these are equal. So the area of the square is equal to AB square, that is equal to under root of 18 square, that is equal to 18 units. So now the area of the square is equal to AB square, that is equal to root of 18 square, that is equal to 18 units.